All right, good morning, everyone, and thank you for joining us uh, for today's training on best practices for electrical bearing protection. My name is Sean Clary. I'm the e-marketing specialist here at Electro Static Technology, the manufacturer of EGIS shaft grounding rings. Our presenter today is Ken Wagerson, and before I turn the microphone over to him, I am going to do a little housekeeping. So you all know what's what if this is your first rodeo with us here. Um, First of all, we have a handout section in GoToWebinar. There are some resources you might want to download from there. We have a PDF of the presentation Ken will be giving. We've got a copy of our bearing protection handbook, and we've also got a copy of a technical bulletin that we put out on hazardous environments. So class 1, div 2, class 1, div 1, and I forget what they're called under IEC. But all right, so there are those. When I started the webinar, you all heard that all attendees are in listen-only mode. If you have any questions as we go along, please type them in the questions box, and after the presentation, Ken will address those. And at that point, we'll open your mics so you can ask questions. Two more things, and then I'll give it to Ken. This presentation is for credit. We will be sending you a certificate of completion, hopefully within the next couple of days. It may be a little longer, but I'll do what I can to get those out to you. And the second thing is, if for whatever reason you need to drop off, or if you're unable to make it today, well, then you can't hear me talking. So, but if you need to drop off early, we will be sending out a link to the recording of the webinar tomorrow. So you will be able to pick up whatever you missed. Likewise for any of your colleagues who might have registered but not been able to come for whatever reason. All right, so with all of that said, I will hand the mic to Ken Wagerson. Ken?
Hello, everyone. I'm going to say good morning because speaking to you from Central Time in the United States, it might be various times wherever you're located, but Sean gave the introduction there, and I was going to say about it being for credit, but he already covered that. So we have a webinar that's divided into 3 parts. The first part is going to describe the background and the cause of what's going on. The second part will describe how to detect if that happens to be the case in your facility or in a project that you're designing or working on. And then how to prevent or how to mitigate. And prevention of early bearing failure is exactly what we're talking about, like here on the first slide. So the EGIS shaft grounding ring does not necessarily extend bearing life. What it's designed to do and what our goal is to prevent early bearing failure. Most people will be happy with bearing life of approximately L10 or 100,000 hours plus or minus, depending on how your specifications might go. When you have bearing failure in 1 year or less, not really too happy. And so that's our goal, is to prevent, early failure and get those bearings to live their normal life that you might expect. When a motor is operative on a drive is kind of the fastball down the middle in this particular webinar, but motors that are not on drives also exhibit this problem. Also DC applications and even fractional applications exhibit this problem as well. And there's a lot of applications now that are just mitigating the unwanted shaft voltage spikes instead of actually protecting the bearings. They're just taking that unwanted shaft voltage and taking that to ground. So the motor is operative. It builds a little voltage. There's the red plus sign right in the middle of this first slide. This voltage is small in amplitude. It's typically between 5 and 50 volts. So it isn't really something that even if you accidentally touch the turning motor shaft, you can even detect. You would not even feel that kind of a voltage. But the bad news for the bearings is it looks to go to ground. And when it does that, it goes to ground in a high frequency manner. 1 to 2,000 discharges is common per second. And those discharges are going across the bearings, as you can see on the slide there. So that oil film, or I call it a grease layer, and that grease layer for new grease looks about like that color. It's a nice dielectric. When the motor is cold and the grease layer is a little thicker, you get a dielectric stopping that lightning bolt from occurring. That lightning bolt wants to occur though, go across the grease layer on the top and the bottom and find its way to ground, because that would be discharging the energy that's on the shaft of that motor. So what happens is that dielectric value of the grease layer changes as the motor operates. As the motor operates, the grease layer becomes hotter, typically becomes thinner as well. That lowers the dielectric value, lowers the resistance to that lightning bolt occurring. So that shaft voltage can build up, and like I said, 5 to 50 volts is common, but it can build up where you're getting discharges at a lower, easier, you might say, easier, lower voltage, and that can discharge across the bearings there, arcing, going to ground. So it's not really a nice flow, it's an arc, because you have the dielectric layer of the grease layer that has to be overcome by the energy, and that arcs across the bearings instead of flowing, and that arc is that lightning bolt there, and it does a little bit of damage to the steel. So the focus here really in this webinar is very much this lightning bolt right here. This lightning bolt is what we're trying to get rid of. As that occurs and goes across the bearings, you're doing some damage to the steel. And no, the damage to the steel is not this much in this first slide, but we'll show you a slide coming up that gives you a little feel for exactly how much damage is being done to that steel. So kind of keep this lightning bolt in your short-term memory here for the next 20 or 30 minutes as we go through this webinar. That's about how long it takes, about a half an hour. And then we do open it up to Q&A. We're not in a rush. We can answer as many questions as you may have as we get to the end here. So a lot of people have heard that variable frequency drives are much in use. I'm sure most people on this webinar know that already. The variable frequency drive is going to provide energy savings. Been around for a while. I'm going to say probably 25 years, maybe plus or minus. But it's really come into widespread use here in the last 5 to 10 years. Many facilities have most, or if not all, of their motors on drives. You go into a processing facility or food processing, or even HVAC applications, data centers and others, and you're going to see 80, 90+% of the motors on drives because of the energy savings. And you can see the cost savings there on this slide. This one on the right here is going to be a lot lower in cost to operate than this one here on the left. And that number may vary based on the utility rates and all that, but it is going to be lower. EGIS comes into the equation here regarding sustainability. So if you can initiate this energy savings by adding the variable frequency drive, then you can want to maybe sustain that for a while. You don't want to just have that energy savings and then all of a sudden you're sending motors out for bearing replacement, or you're replacing the entire motor. You're going to kind of put it in one pocket, take it out of the other, and the net result is not going to be good. So EGIS comes into the equation where we try to help you sustain the energy savings, prevent the early bearing failure, and allow those motors to run on those drives for a long time and accumulate a nice amount of savings. But back to the physics here. The physics is pulse width modulation output, PWM. It's kind of a high on-off switching speed. Some of you might be familiar with drives. If you are, you know all about this. The drive output is typically graphed like you see up in the upper left-hand corner there, this little bar graph. So this drive or inverter is inverting DC back to AC, simulating a sine wave, sending it over to the motor. And that sine wave is pretty good. You can see it there. It simulates it better all the time. It is a little fuzzy though, not perfect. And you are going to see a little residual voltage build up on the operative motor shaft there, which again, many of you on this webinar might already know all about that. But another consideration for you is on the bottom part of this paragraph, the parasitic capacitive coupling between the stator and the rotor. So you might want to take a look at that, and we have a slide to focus on that a little bit here. So when you bring that power into the stator, as you can see on the bottom of this drawing here, it's separated from the rotor by an air gap. That's the classic definition of a capacitor, two conductors separated by a dielectric. So capacitively, the shaft voltage is induced, as you can see in this drawing here, by having this stator have the power, and you then have capacitively inducing the voltage on the shaft with these little plus signs here. And this little bit of shaft voltage can find its way across the opposite end bearings, as this drawing shows, or maybe across the drive end bearings, both of those being on the motor. And that's what we've been talking about here in the start of this webinar. You're going to look at your motor bearings. But another thing to look at is what's downstream, this orange part down here called load in this particular drawing or this slide. This can be a number of things. One example I would give you is a gearbox. We had a large paper mill that had a gearbox and the voltage went downstream. This was a conductive coupling and it striped the gears, causing failure. That's an $80,000 refurb, not to mention the cost in and out and transportation, in and out of the mill and transportation. And those all added up to, a couple $100,000 in expenses because those gears had become striped. In that case, the EGIS shaft grounding ring was installed here on the output of the motor. When we do these trainings in person, of course, we have samples of the ring to show you and things of that nature. But on the webinar, you're just gonna kind of have to wait for a minute. We'll show you some ring photographs shortly. The ring was put on here on the output of the motor. It stopped the shaft voltage from going downstream and biting the gearbox. Another example was a compressor. A similar environment where it was a large motor and it was a conductive coupling. In this case, the electrical erosion occurred right here at the seals of the compressor. The refrigerant escaped and the seals aren't that cheap either. So that was kind of costly on the replacement of the refrigerant, the repair of the seals. And again, the solution was to nip the shaft voltage, give that shaft voltage a preferential path to ground by putting the ring here at the output portion of the motor. And you can prevent that problem. The third example was pump motors. This was at an oceanarium. And unfortunately, they put the drives in the oceanarium a really long distance away from the motors because they didn't want them in the saltwater environment. That created a lot of reflective waves on the between the motor and the drive, and that created a lot of shaft voltages that were going across their pump bearings. Now those were only like 2 horsepower motors, 5 horsepower motors, but they did lose those bearings on the pumps, had to replace a number of them, and more importantly, they had downtime. Downtime can be, of course, the main culprit. Oftentimes, downtime's a lot worse than actually replacing the bearings. In that case, they had a very expensive aquatic wildlife there in the oceanarium, and they didn't want to have downtime on their pumps. So they added, as it turns out, EGIS shaft grounding rings, and they also added sine wave filters. And that's something that we never discourage. Now, again, we're trying to stop early bearing failure. So if you decide that you'd like to use a couple of different methods, some people will add sine wave filters. We encourage the use of that. Other people, they'll have some best practices going, keep the drives close to the motors. That can definitely help. Have the right cable between the drive and the motor. Have the right cable grounding not only the drive, but grounding the motor frame, braided, so you can transmit that high frequency voltage on the surface of the conductor. Add shaft grounding rings, things of that nature. You can even use insulated bearings depending on the size of the motor. We could talk about that a little more in a minute. But those are kind of some best practices, and you want to definitely be aware of those best practices, either if you're specifying drives or if you're actually the one that's keeping a facility running. I just gave you the very, very short version of a handful of best practices, but certainly you should be aware of those and looking those up and fulfilling the best practices with your drive and your motor in combination, and you'll have a lot better success with energy savings without a lot of bearing failure or motor replacement. So that's kind of the end of part 1. Here is part 2, how to detect. One way to detect this is to look at the bearings. You want to take the bearings and take a look. Now, a lot of times repair shops will do what you see in this slide here. The ESA organization is the mothership of repair shops, and they're telling them to look at this bearing fluting. And the grease layer as well. The grease could be black or it could be blue. When we do these trainings in person, we bring in samples of the grease and display those samples. But basically, the grease is blue like it was in that first slide, typically when it starts out. And then as it becomes blackened by carbon deposits and metal flakes, the dielectric value goes down. And in this steel, you're looking for the electrical discharge machining, or EDM. EDM creates a lot of these pits, and you can see there, you're cutting the bearings open in the one photograph. You're looking at the grease, is it black or is it blue? And then you're looking at the bearings for this frosting or this fluting. Now we have a slide coming up to show you a better view of that here. This slide shows you the fluting results. These are inner race and outer race from a larger motor, larger bearings. this outer race, I have both of these samples actually. Both of these samples are something that we bring on the in-person training, and you can pass these around the room and get a look at them. Sometimes the railroad track or fluting is so pronounced that you can feel it with the back of a fingernail. And here's kind of a close-up of this. When you're able to open up the bearings and look for electrical discharge machining, you're seeing the frosting. The frosting is in the upper right-hand corner, visible to the naked eye quite easily. And yes, it's usually down the middle of the race. Not always. Vertical motor installations, it might be offset. Then you move down to the lower right-hand corner. What happens is the discharge of the lightning bolt there, that electrical discharge, creates a change in the metallurgy on the very surface of the steel. In the upper right-hand corner, you're going to get some discharges, and they make that steel more brittle. And you go down to the lower right-hand corner, and you get a railroad track. That happens by nature. That happens just like it's shown right there. Uniformly around the bearing race is almost always the case. Sometimes it finds an easy spot and it discharges on every revolution. It usually doesn't wait that long, though. Again, thousands per second. So it creates a bit of a railroad track there. So now you opened up some bearings and you don't see the frosting, you don't see the fluting. So maybe it's not electrical discharge machining, maybe it's something else. There's other modes for bearing failure. We know there's commonly 20 or 30 of them that the bearing manufacturers will show. They put out a wall chart for the repair shops to use. But what you do want to do is double check it, and that's when magnification comes in handy. You go to the lower left at 1000 mag. 1000 mag is easily accomplished like with a microscope. You can photograph what's underneath. You get the moonscape, but then go up to the upper left. The upper left is what I want you to focus on because that is the lightning bolt. Look at that EDM pit. That EDM pit is visible with an electron microscope. We have our factory in the state of Maine in the United States. We do not have an electron microscope in the factory, of course, because they're very expensive. We lease a little time at the University of New Hampshire on theirs, and we can see these pits. Of course, you can get that done other places as well. That EDM pit here, which I'm highlighting with the arrow, that is the lightning bolt from the first slide. That's what it looks like in the steel. This slag around the edges ends up in the grease. So one discharge, we're not going to have this webinar today. You get 1 or 2,000 per second. Now you're in the lower left. You get the moonscape. You get the melting and the refreezing. It happens for a little longer. Now you have the visible frosting in the upper right. You get the discharges, and then the lower right, that's the fluting failure. You might also have some indicators. The bearings would have probably a higher temperature when they're getting into frosting and fluting failure mode. During operation, you can hear the whining. The whining is an audible whine that you can hear with the discharges. That's an indicator that you're having electrical discharge machining. Again, higher temperature on the bearings. You also would have vibration increase. Very often this problem is diagnosed by vibration analysts. Vibration analysts will bring their equipment in and they will check the vibration on the bearings. Many of you might be familiar with that. A lot of them now are also measuring shaft voltage. We're going to talk about here coming up in the next couple slides. They'll bring in a scope and they'll measure the shaft voltage. Not all of them, but what they'll do is tell you with the vibration equipment that they indicate fluting. They're almost always right when they do that diagnosis. And so those would be things you're looking for there. The temperature increase, the whining, audible whining, and the vibration increase would be at least 3 things right there. And there may be a couple of more, but those would be things you'd be looking for if you're suspecting this. Using the scope is like in this photograph here. In this case, our engineer was visiting an ethanol plant, and we were a rooftop, and he's holding a nice handheld 100 megahertz capable or better scope. It's got, you know, the coating around the edges in case the scope is dropped. It's very durable. It's battery run, and it's got a port to download the images onto a memory stick. Look at the red probe there going out to the turning motor shaft, measuring shaft voltage there versus ground. Usually it takes longer to get the guard out of the way than it does to take the readings. So this is kind of a nice setup with the mag base here. Mag base is not necessary. When I take these now in the field, I do not even bring the mag base anymore. Almost always when I'm in the field, Touching the turning motor shaft with the probe tip is done by the employee. Like if I go in a paper mill or if I go in a data center, the employee has to do that. They don't let the visitor do that. So the visitor is myself over here on the left, operating the scope. It has a nice run stop button feature, and you can capture images. EGIS has added a private label scope to our product line a number of years ago. This has been highly successful. By us sourcing this scope, we were able to take half of the cost out of it. Yet it's a very, very good scope with lots and lots of functions. There's like a 200-page handbook that comes with it and describes all the functions. We only typically focus on the shaft voltage testing. Our moderator for the webinar is Sean, and he's in that photograph there. It is kind of just like shown in the photograph, not too difficult. He's got it set up there to test the shaft voltages. Usually only takes less than a minute to get the readings, and you can capture them on the scope screen. And here's what you get. Really nice little capture of this image. This was only a 1 horsepower motor, so yes, it happens for small motors as well as large. And this was an inverter duty motor, and this is a kind of an old photograph. It's 20 years old now, but it's still very, very appropriate. And still today, this is exactly what's going on. The inverter duty motors do have better insulation on the windings, but only in the last 10 years have the motor makers really been putting on large quantities of shaft grounding rings. They are doing that though, and we'll cover that before we finish. There's your shaft voltage, 36. Remember, it's common to be between 5 and 50. This blue oval here in the middle, this is the lightning bolt. So this is what you're looking at when you see a discharge. It could be positive or negative, of course. And you're getting the rise in shaft voltage. The vertical line is the arc across the bearing. Very high frequency. Every little box here, this is set at 20 microseconds. So this is a very high frequency device. And that's why you need the 100 megahertz scope. You can use any brand or any style, large, small, old, new. But really you want to be looking at, a 100 megahertz capable. The EGIS probe tip here in this prior slide comes in handy for putting on the end of the probe here, as you can see on the slide. This probe tip is touching the turning motor shaft. It's got the microfibers, so it does not shake around. It's able to sit against that turning motor shaft very nicely. They come along like this in a 3-pack. On this slide, you can see them right here where the arrow is. And then you can pick up these readings pretty readily. You hit the run stop button, you capture the readings. You either take a photograph of the screen with your cell phone, which is what a lot of people actually do. It's so easy. Or you download the image to a memory stick, a portable thumb drive, and you can then save those as a record. So really, when you're seeing a discharge, it doesn't mean, in the next 5 minutes, the bearings are going to fail. What it means is that you're having discharges and you have to keep an eye on it. Over time, given enough time, is that going to be 2 months, 6 months, or a year? Not sure. But over that kind of time, short time, you're going to get a lot of discharges. And those discharges will add up eventually and create damage in the steel, as we saw earlier, and cause early bearing failure. The scope is a great preventative maintenance tool. Many factories, like paper mills, are using these now. Even a person like myself can use the scope, and it's not that difficult. Sean is a little more the expert. The beauty of it is having Sean in our factory ready to help you is if you're out there taking shaft voltage measurements, you can reach out to myself or Sean if you have technical difficulties, and we can walk you through that. And if they get bad enough, then it'll be Sean and not me. But in any case, we will get you an answer, and you'll be able to accomplish this. So that's the end of part 1, the background. That's the end of part 2, how to detect. And now we go into mitigation. Obviously, in person, I bring samples of these rings. You might have seen them already. They're mostly aluminum. They can be stainless or other materials that are metal and conductive. They go around the entire shaft OD of the turning motor. That's one of our patents. That's actually a feature. You want to have redundancy in case part of the ring gets fouled for any reason. You still have functionality. And a lot of them come with clips to hold them on. Some of them come with holes in the ring to bolt them on. Some of them come with a press fit feature. Some of them come split, so you can wrap them around the shaft without uncoupling. But all of them have these hair-like microfibers. These are on the ID of the ring. These hair-like microfibers are soft to the touch. They're not carbon. They are a synthetic. It's our intellectual property. Obviously, I have no idea exactly what they're made of, but if you wanted to take a sample and spend some money at a laboratory, you probably could get some pretty good data. In any case, when you take these fibers and have them in function, they're flexible. They flex instead of shear. They're soft to the touch. And they're made such that the tips of them in this slide right here touch the turning motor shaft. A lot of them are touching, and that's direct contact conduction. Pretty obvious, pretty logical, common sense approach. A lot of them don't touch though. That's where kind of the fun part comes in with the microfibers. These ones that don't touch the steel are still working. The tips of the fibers are where you get the conductivity. This is non-contact conduction. So they have two types of conduction, the fibers. A lot more goes on with these rings than meets the eye. People look at the grounding ring and say, wow, that's really a simple product. You know, maybe it is, but it is designed carefully, and it's also difficult to produce. It's a product that has a lot of fibers that are hair-like. Those have to be managed. Those have to be captured. Those have to be cut, and those have to be clamped and held in place. There's a lot more going on with the microfiber processing than most people realize. And the beauty of them is explained on this IEEE paper. You might look at this IEEE paper and go, wow, that's kind of an old paper. Well, you know what? It is old, but it still works fine. It's a paper that describes what's going on. And that paper won first place in 2007 from IEEE for most innovative product. You know what? It's not easy to get first place on an IEEE paper. This was written by our general manager at the time, along with a professor who was at the University of Wisconsin at the time, and now is teaching in Europe and is a consultant for our company. This dual methodology here, or nano gap technology as we call it, nano gap technology is unique to the product. It allows the transfer of energy even with small gaps between the fibers and the steel. And that would be done through ionization and the tunneling effect of the electrons. This is a very interesting scenario. It's not a block of material or a stiff and brittle carbon. It's actually a soft, flexible, conductive material, not affected by grease and oil. And what you really are doing here is telling that shaft voltage, hey, I've got a lower resistance. Go through me. Don't go across the bearings. When the flow is through the ring, it'll be affixed to the frame and taken to ground. You're going to see in that close-up there, the fibers are very thin. Millions are installed. How did we ever get to millions installing? Well, a lot of them are because they're specified. Many engineering firms specify us in their design of new structures, or maybe they're building an addition to a paper mill. We had a paper mill in Green Bay, Wisconsin. They were putting in a large, and when I got in there and saw it, it was a thing of beauty. It was state of the art. Everything was state of the art, and they specified the grounding rings on all the motors before they even built the new line. So a lot of them go on with HVAC applications or data center applications, but a lot of them go on in production facilities, paper mills, plastic processing, and they're actually specified by Microsoft, Google, Facebook, Eli Lilly, Georgia Pacific Paper Mill. Heck, even the state of Wisconsin specifies them in their motor spec. So a lot of them are specified in companies' motor specs. Intel out on the west coast of the United States has recently added them to their motor spec, and then they also get specified by engineering groups, and that's why there's millions installed. Last a long time. So some of you on this call, you might know that maybe there's no such thing as a maintenance-free product. Well, I'm going to show you one here that's pretty darn close. 200,000 hours of functionality. That's north of 20 years running 24/7. That's a long time. And you're trying to get 10 years out of your motor. The ring will last for 20. Our first installations were done 20 years ago right now in 2005. The very first installations were at Purdue University in Indiana in the United States. And we kind of keep an eye on those installations to make sure they're okay, and they are. And that's a 24/7 operation. The fibers flex instead of shear, and it's a wear to fit type product. So they can only wear out so far. Again, they don't even have to be touching the shaft to work well. So you're putting this ring on, and then it's maintenance free. And we can say that because they're put on inside the motor a lot. You can't even see them. So, you know, they're really maintenance free. You're not even thinking about maintaining them because you don't even see them. A little summary. This EDM starts out by the buildup in the shaft voltage, the arc across the bearings of the lightning bolt. Remember that lightning bolt we talked about in the first slide? Then it looks like this on a scope. I have no idea how they got that arcing event to sneak in there like that. But Sean sent me this slide and it works, so I put it in. That arcing event is what we've been talking about. And when you add the grounding ring, you're going to provide an alternate path to ground, a preferential path to ground. Your scope's going to look like this. So when your scope looks like that, you're in good shape regarding shaft voltage because your grounding ring is bleeding off that shaft voltage, not allowing it to build up enough to arc across the bearings. Remember, it has to overcome the dielectric value. If you keep it below that level, it cannot arc across the bearings, and a little bit of noise is not a discharge. Up here is a discharge on this upper right. Lower right, those are not discharges. When you use your scope, when you see what's on the lower right there, you're good. That's what you want to see. You use a scope when you see what's on the upper right, not a good thing. Add the grounding ring and improve your situation. What you get out of it is reliability increase. People that are in the reliability field on this webinar understand that you take a failure mode, you understand it, you do something, you either change your design or your practice, and you prevent that failure mode. Understanding a failure mode and then taking it away improves reliability. Always a good thing, especially if you're in a data center, you don't want downtime. Very, very expensive. So you give the shaft voltage the path of least resistance. One ring on motors up to 100 horse, drive end, opposite drive end, internal, all good. And look at that green bar on the bottom. That green bar is important. You want a good ground. In a perfect world, you have it set up just like this. You have a ground for commonality between the drive, the motor, even the driven equipment, and that should be grounded with braided. I'm going to show you a slide on that in a second. The right cabling is important. If you get the right cabling between the drive and the motor, you're in good shape on that too. You want that, you know. This is like kind of a product that's called bonding. You're kind of bonding the rotating rotor of the motor. You're bonding that to the stationary ground, the stationary rotor or stationary ground. So in a way, you're kind of bonding the shaft voltage, not necessarily grounding it, but that's terminology that we're kind of one way or another. The bottom line is you're taking that energy off of the rotor and you're stopping it from causing a problem. Bigger motors do have bigger problems though. When you get to 100 horse or above, you're talking about number 2, circulating current due to the high flux. Look at this graph here. It's kind of busy, but it's simple. The yellow is the capacitively induced. Remember we talked about the motor being a giant capacitor? Here it is. Yeah, it gets a little bigger when the motors get bigger. This is 500 horse down here where the arrow is. A little bigger, but you know what? Not too bad. Bad news is the red line comes into play. The red line is the circulating currents. That will creep up and it's additive. Now you're looking at the blue line. Not good. This bearing currents on the blue line are tough to handle for the bearings. Here's how you stop the problem. You use the grounding ring for the capacitively induced and you add an insulated bearing opposite. Yes, these can be flip-flopped. You add the bearing, insulated bearing, which could be a ceramic on the outside of the race, or could be a ceramic ball bearing. That ceramic ball bearing is excellent. They last a long time and they're non-conductive. Also expensive though. Don't waste your money and put on 2 insulated bearings. Just one opposite the ring. The ring is way, way, way cheaper than the ceramic bearings and does a good job. And let's talk about proper grounding of the frame now. When you ground that frame, it should be braided. A high frequency ground strap is really a good idea. Your high frequency discharges go on the surface of the conductor called skin effect. The electrical engineers here on this webinar are chuckling because that's like electrical engineering 101. But anyway, that's the way it is. And when in doubt, make sure you have the motor properly grounded. So sometimes we go in a facility and they add the grounding ring and they're like, hey, grounding ring's not working. I'm still having these discharges. Really? Is your frame grounded? And then when you find out that no, it's not, you add the ground strap, all of a sudden you've solved the problem. It can be this simple, like a short ground strap like I'm showing here, but it doesn't necessarily have to be. Very often the grounding between the drive and the motor is proper, and it does go back through the conduit, and that's fine too. Well, what we're trying to say with this slide is don't assume the motors have proper grounding. Verify that they do for the high frequency discharges. You'll save yourself some future headaches. These are the larger rings called Pro rings. Pro rings are typically 500 horsepower and bigger for low voltage, all medium voltage, and then DC motors 300 and bigger. This is a photograph in a paper mill right here of an actual installation. These brackets are available from us, or you can use your own if you so desire. This grounding ring was installed there, and it's bleeding that shaft voltage off with 6 rows of fibers instead of the standard ring, which is 2 rows of fibers. Plus the fibers are more dense, giving you 4 to 5 times as much capacity. These have been used in critical applications. You know, you have some certain motors in facilities that are typically the larger motors do a lot of work, you might say. They're critical. You lose them and you're losing a large pump, or you're losing a large fan, you're losing a large gearbox. Whatever it is you're losing, you want to prevent that. Bigger motors usually have bigger problems. Use the EGIS Pro Series. These are available even more robust than this with more microfibers, and they're available with a monitoring capability. The monitoring capability is a beautiful thing. You are able to put a ring that's used for monitoring of the voltage. You can run a lead off of that monitoring ring and analyze that with a scope a little more remote from the process. Some processes are very hot or very dangerous, like in nuclear applications. We have an excellent product for a nuclear application, which has been widely used over the last 7 to 8 years in nuclear plants across the United States. We have an expert working with us on that market who can walk you through that and give you examples and photographs of exactly where that application is. You certainly don't want downtime with nuclear applications for obvious reasons. Back when we came out with the product in 05, it was retrofit. We're talking about the top of this slide. Look at these rings, they're split. Nice for going around the motor shaft without uncoupling. Looks a little clunky there. You can use any size clip though you want, and the clips aren't necessarily that big. This demo on this sample, they put the largest clips on there just to show you what they look like. These can be bolted to the frame or put on with a conductive epoxy, which we also have cataloged and available. The conductive epoxy has silver in it. It's just like regular 50-50 mix epoxy, very, very strong. Do not get that on your fingers, and because you're going to have issues cleaning your hands off later. Keep it on these clips. Pair a little metal with a Dremel or a die grinder of some kind, and get these clips on the bare metal for good conductivity. And you can wrap that ring around, and look at this is exactly the way these were done. Hospitals, universities, and others for many years. Motor repair shops got involved early on in the game. They are experts at what to do with the motor. They know where to put the ring. They know how to install it. The beauty of it is they actually get it right. They're not guessing at it. They get it right, either inside or outside the motor. Easy way to do it is have the shop put your ring on, the grounding ring on, when they do the repair, or when they send you over a new motor. Have them make sure the grounding ring is installed. Maybe they're going to install it themselves, or maybe they're going to purchase it that way. And that's the bottom here of this slide. This started in 2011. The grounding ring started to go on motors when they were being built. This little nameplate modifier here where my arrow is highlighting, it's showing that, yes, there's a grounding ring in this motor. You can't see it because it's inside. It's in here on the bearing retainer. Some of them go on the outside on the drive end or the opposite drive end, that's fine. But when they go on the inside on the bearing retainer while the motor's being made like this, this is when you're really winning. You're winning in a big way. You're available and ready to ship from stock. A lot of motor makers are having that available now. You don't have any labor time or cost or consternation or difficulty putting the rings on yourself. It's a very low cost because they're putting them on high speed with air-powered tools. They're buying them from EGIS at a volume basis at a low cost, and that adds up to lower cost. And they're also typically warrantied better. Many motor makers will have a warranty up to 3 years. against bearing fluting when they add the grounding ring. EGIS has a optional 2-year extended warranty that you can register for. That would get you a total of 5 years against bearing fluting. If you have an operative motor on a drive and it's run for 5 years with no signs of bearing fluting, you're in good shape. You're going to make that 10-year mark pretty much 99.999% of the time, if not 100. That would be a good situation for yourself. A lot of them are being added by ABB Balder. This is a lot of pump motors that they added them to. Again, these come out of the factory with the ring already installed. Easy does it, low cost. A lot of them are being added by US Motors on their vertical hollow shaft. They also add the insulated bearing opposite, which is best practice. Really nice motor, market leading. And these are other motors for cooling tower applications by US Motor and Nidec. These cooling tower applications exist with data centers, power plants, processing facilities, and others. Nice way to add the ring. WEG has them available for Class 1 and Class 2, Div 2. You would talk to WEG about that Class 1 Div 2 application. They went and got certified for this. And now they've had Class 1 Div 1 for many years. Now they have Class 1 Div 2 as well. As Sean said, we've got a little bit of a brochure attached. You can download that. I would encourage you when you're specifying or buying a new motor and it's Class 1 Div 2, talk to WEG. That's where you're going to have some good success. They have the approval all around the world for that installation. Marathon added Cymex years ago. Marathon is now part of WEG Group, and it's called Marathon Electric officially. This Cymex motor, they decided to add the grounding ring on all of them, whether you ask for it or not. This is a Cadillac type of a motor. Very, very high efficiency, very long life. There's no reason to have a Cadillac and then have the bearings on your Cadillac motor fail in a year. Nobody wants that. So they added them without asking. Nice motor. A lot of drives are being added. We think that's going to continue. It's gone on now. We are a 20-year-old operation. We're not a 20-year-old company. We're about a 40-year-old company. But we were doing static mitigation for other applications. And then 20 years ago, the grounding ring was invented and introduced to the marketplace. It's really taken off for many applications. And before I stop talking here, I want to tell you, it's not all bearing protection. A lot of grounding rings are put on to bleed off unwanted shaft voltage spikes. So when you're monitoring a turning motor, you're monitoring it for vibration, temperature, speed, whatever, you're sitting back in the office there in the paper mill with the air conditioning on, and you've got the line running out there where it's hot and humid. It's nice to have something being monitored. When you're monitoring that turning motor shaft and watching your laptop or whatever inside that office, if you have unwanted voltage spikes, now you're wondering, what's going on? I'm not getting good readings. Now you got to go out in that hot, humid paper mill and figure out what your problem is. Your problem might be unwanted voltage spikes. You might also have that problem if you have an electric vehicle, because electric vehicles, they have a lot of obviously highly sophisticated controls. They don't want, random spikes on the traction motor drives or anything like that. We've also got these grounding rings not only on the electric cars, but we've got them on drive motors for locomotives, both heavy duty rail and light duty rail. We've got them on bulldozers, electric bulldozers where they burn diesel, but they burn it in a smaller amount and they power up a traction motor. We've also got them on mining trucks, those applications. Grounding rings are put on spindle drives for high-speed machining motors. They're put on disk drive motors. Seagate and Western Digital have been putting a grounding ring on for about 15 years already. They put them on all the time. We've even got them on other devices. There's a blood filter that they go on because when it's in use, it accumulates static. So the grounding rings bleed that off. So even though there's a lot of drives on motors, I just wanted to give you some other food for thought. There's a lot of applications for the grounding product that really aren't necessarily protecting the motor bearings, but they are helping you ensure reliability and improve your reliability. So when you're looking at reliability improvement, where you're looking at preventing expensive downtime, where you're looking at your uptime percentage being higher than it is now, you might want to consider the grounding ring. That's it for today's webinar, the presentation part. And now Sean and I will be available for questions.
All right, thank you, Ken. We've got a few in the queue here. Let me see. Our first question came from Julian, and I actually answered this one, but I think it bears repeating, so I'll put it to you so everyone can hear, Ken. For what motor size do you recommend shaft grounding rings? And do you have grounding rings for all motor sizes?
Yes, absolutely. I'm going to go back to this slide here so you can see it while we're talking. In this particular case, this is just a 1 horsepower motor. So I've even had applications for fractional size motors, quite a few applications just in the last 3 or 4 years. And then, of course, they go as big as you want them. So yes, the grounding ring is made, and I think you're listening well to this webinar, because what this shows here is that, yes, those tips of those fibers, the tips of those fibers have to be touching the turning motor shaft. So we don't just jam a bunch of fibers up in there and hope for the best. They're actually made such that the tips touch the steel. And they touch the steel because that's where the work is done by the fibers. The bleeding of the energy is done with the tips touching or not touching, barely, but they're close, barely, really close to the steel. And that's what bleeds off the energy. So what EGIS does is makes the ring to fit a certain size of shaft OD. And, you know, that can be done in a singular application where you measure that with the calipers, and we make that, grounding ring to match up a certain size motor, a certain size application like this right here in this paper mill. Or you do that with a known shaft OD like the U dimension. We know what a lot of them are. So we catalog them and offer them for known sizes. They're easy to find because you're going to say, hey, I've got frame size XYZ. We're going to look that up and have a part number for you immediately. We're even doing some stocking of those parts so that we can improve our lead times. So you get a lot of consistency across the motor market, or there's NEMA specs, and so therefore the shaft ODs are amazingly consistent, and we make the rings to fit that way. They can, however, be made basically, you might almost say, any size, even up to 30-inch, and that's a big one. You're not going to get too many that big, but you're going to find a lot of them that are 6-inch, 8-inch, 10, 12-inch, no problem whatsoever for us to make those. But of course, many of them are only a 1-inch or 2-inch shaft OD, and the volume there is high because those are HVAC applications. We do have them for any size.
All right, thanks, Ken. Our next question is an interesting one, and it comes from Serge or Sergey. I'll unmute him. I started to answer this one, but I haven't heard of this happening. Anyway, enough talk. His question is, do we have experience with electrical damage in ceramic balls, in ceramic ball bearings, silicon nitride balls, and what does it look like?
That's a really good one. I've never heard of that either. You're right, though. It is silicon nitride material, so you're on it. I've got a sample of one of those that I bring around for my in-person trainings. I've never heard that. So I'm going to say check out other possible things going on. You might see something on there and you might assume it's electrical discharge machining. One thing I would say is look at other things that could be problematic. Maybe the silicon nitride is a little more brittle than you want it to be. Maybe it broke out a little easier. Maybe. I would check out those silicon nitride, but also what I would do is, we kind of showed it earlier. Take some readings on your application if you can. Do some of this here where you're measuring the shaft voltage. The shaft voltage tester is so good because it accumulates data for you and you become more knowledgeable of your process. So you might say, hey, I'm pretty sure this is electrical discharge machining. I must have shaft voltage building up, and it's going across my ceramic bearings and it's causing problems. Well, have you measured the shaft voltage? Because if you have not, you want to verify what's actually going on with the operative motor or whatever your application is, and find out if you actually have a shaft voltage buildup and you actually have discharges. Remember, you can see them pretty nicely like this on a scope. So that helps you understand, do I have the discharges? First of all, fine. Then maybe you can mitigate them with a grounding ring. And instead of having them, you know, cause problems for you. But no, I have not myself in my 17 years of doing this ever seen a ceramic ball bearing with pits or marks on it from electrical discharge machining. I have not.
All right, thanks, Ken. For any interested attendees, that all applies to bearings with actual ceramic rollers. There are also so-called insulated bearings, like SKF makes Insucoat bearings, which have a thin layer of aluminum oxide usually around the outer race. Those bearings, it's uncommon, but those actually can suffer fluting damage. I wrote a blog post about it actually. If you go to blog.est-aegis.com, or just go to our website and click on the blog button and then use the search bar to look for insulated bearings, you will come up with that article. It's not all that common, but it does occur, and usually any damage accrues too slowly for you to notice, like the motor dies of natural causes before the fluting gets bad enough to even be noticeable in those bearings. But all right, our next question comes from Clyde, and Clyde actually has a few more questions coming up, but his first one is, with internal shaft grounding rings factory installed, where do they connect the ground to? To the motor frame?
When they're factory installed, and I got a photograph coming up, so I'm going to that right here.
And
It
Clyde, I'm
can
going
be.
to unmute you from our end if you want to talk to Ken directly. Oh, by
So
the way, as I read your questions, I can open your mic from our end, but after I do that, you also need to unmute yourself. So it's like it's a double lock process. Clyde, I see you got it, so I'll shut up now.
So when the rings are installed by the motor makers in the factory, as shown in this slide here, they will typically hold them on with steel screws. So the conductivity is pull the shaft voltage off of the shaft with the microfibers, where my little arrow is on this slide. The microfiber is conducted to the frame of the ring. The ring then is held on with steel screws to the bearing retainer, which are conductive to the frame of the motor. So the conductivity requires no external ground wire. Years ago when the grounding ring was first being used, there was a motor maker who was doing modifications and they were using a ground wire. They dropped that. They were using a ground wire because they thought, wow, we're going to have to, right? No. After a few years, it just became cumbersome and they dropped it. So the beauty of the grounding ring is you don't have to use a ground wire at all. Now, does that mean, of course, that you cannot use a ground wire? No. Like some people for these pro rings, the big applications, and they like to use an external ground wire, and that's not a problem. They can, but those are usually small volume applications. The large volume applications are done like this, so there's no ground wire needed.
Okay. Thank you.
Yep. Anything else, Clyde? Sean said you might have a couple more.
I just asked, what's the largest motor that you've ever installed Aegis ground rings on?
Well, in this slide here, you see the available shaft diameters all the way to 30-inch. I know we did some very, very large ones for the U.S. Navy. U.S. Navy was changing over the drive on destroyers and others to go with traction motor drive. they wanted to lower their consumption of fuel, and they wanted to use the traction drive like in harbor and anywhere they were fine with slower speed. So they had some very large ODs on those. I'm not sure, well, that was the Navy Yard in Philadelphia where they were working those. I did not get to go in there. I think those were 28-inch, I want to say. But anyway, really, there's almost no limit in some regards. No one's ever come to us with a OD that we were was too big for us to handle, because at that point in time we get to a custom scenario and we can make any size really, and we can add fibers, in multiple rows. So really, they're used on all sizes, big and small. There hasn't been anything. We're also used on generators, by the way. Now, some generators don't run 24/7. Matter of fact, most generators that I know of don't run 24/7. They're backup generators and/or they're used for high load or whatever. Now, if you use a generator 24/7 and it has inverter technology like we've been talking about here for the last hour, then you might look at the shaft voltage issues. Sometimes, grounding rings are put on for generators, but again, you want to look at your usage time on that.
If you take the AEGIS scope and you measure electrical discharges, at what level do you take it to the customer and say, look, this is at a certain level. I want to recommend you put on the grounding ring.
Yep, good question. For talking points, okay, and that's just because, the question is asked, we're out in the field, you got to have something to say, and, for talking points, it's usually 5 volts peak. So when you're looking at your scope and you see what we see here, and it's 5 volts peak or more, you want to be concerned about that. But I would be a little more specific, because you're the one that said, hey, I see this on the scope, I'm showing this on the scope, at what level. So when you have this discharge, even if it's less than 5 volts peak, then you have the discharge. So you maybe have
like 50 volts.
Pardon?
That peak that you're looking at right there looks like it's 50 volts. It's 10 volts.
It's actually 36 peak to peak.
Oh, 36.
And
okay.
Every little box, I'm sorry it's not more visible, but every little box is 10 volts. So
10 volts.
It's like 10, 25 roughly up. That's why they said 36 peak to peak, because it's also like another 10 down here. Okay. So, but I would say 5, because, that would be a talking point. But if you take a scope and use it and you see discharges, I don't care if they're 2 volts and you see discharges. Well, then you see discharges, and that would be, something you want to avoid, because those are an energy discharge. Now down here on the lower right where we were, these are just kind of noise, and typically you're not too concerned. But if you see discharges on the top right here, I'm gonna have to run. Hold on. Okay, well, you want to avoid discharges no matter how big they are. That's the bottom line.
All right. Thanks, guys. We have another question from Julian now. And Julian, I will unmute you from our end. And this is a very good question, Ken. I think you'll remember when we used to recommend this. Julian asked, can the rings be installed at both sides of the motor, and that way you don't have to use any insulated bearings?
Yep, we don't recommend that, because when a ring is put on, looking at this slide here, if you put a ring on the opposite end where my arrow is moving around, that will only enhance and allow for circulating currents. So Sean is right. When we were babes in the woods 20 years ago, we didn't know better. And we were, people were putting them on both ends. That quickly went away, though. I mean, very quickly. So for most of our existence, we know that you want to avoid putting them on both ends. And, here's Sean and I, we work for a company that makes rings, and wouldn't it be nice if we told you, sure, put them on both ends? That would double our sales, right? Nope, we're not interested in that. We're interested in stopping early bearing failure. and you do that by one end only. And you're using the insulated bearings because you want to break those circulating currents. And adding the ring only enhances them. So bigger motors, yes, bigger problems, bigger cost. That's true. Insulated bearing is more costly than a ring, but that's the deal. There might be some other things you might want to look at, but for my money, insulated bearing does the job. As Sean said, there's those ceramic coated bearings on the OD of the race. They're not that expensive, and they do a pretty darn good job. So you can get away without adding too much cost.
All right, thank you, Ken. Let me see. I wanna put in there. It appears what I was told about this, for anyone who's interested, is that so you would think that electricity travels through the path of least resistance. So if you've got a ring at both ends, then circulating current would go only through the ring. But that's not actually how it works out. I'm not sure of the exact high frequency wizardry going on here, but when you have that much circulating current flowing, a lot of it also ends up going through both bearings, so you totally undermine the protection that they offer. But all right, our next question comes from Amelie or Amali. I will unmute you from our end. Can installing shaft grounding help prevent stator winding failure?
Not really, not in my experience. Usually, your voltages we're talking about on the shaft are very small, 5 to 50, and you know, they're kind of a different animal. The stator, you know, the windings, you want to have uniformity, and you want to have the higher amount of insulation value. Or you certainly want your motor maker to demonstrate for you that the insulation they use on their windings is right and is good, and they'll do that, because that's kind of a mainstay for the motor makers, is to have consistent windings. They're not, you know, the straighter and more consistent they are with the air gaps and all that is better, and the insulation is better too, for you know, higher amounts. And then the repair shop sometimes will have like a dip tank where they'll dip that into insulation, and then it'll harden on the winding. So this shaft voltage is not really related to that.
All right, thank you, Ken. Okay, there are actually, look at that, there were two more about shaft grounding at both ends. So in case you're just rejoining us, no, you do not want to put a grounding ring at both ends of the motor, only one end. And if there's an insulated bearing, you want the ring at the opposite end from the insulation. Okay, our next question comes from Adam. Adam, I will unmute you. His question is, are grounding rings installed, or can they be installed on ECM motors, electronically commutated motors?
Yes, we do have installations for those. It doesn't seem to be as widely used or in a high volume way, but it depends on what the motor size is too. I think the bigger ones see it more often, and also what it's doing for you. If it's running 24/7, things of that nature. So again, your operative time is important, and you know what it's actually doing for you, how critical it is. So they certainly can be installed on those, and they have been, and they've been successfully used. We just don't see it quite as much volume in that area.
Okay, yeah, just we're the industry I'm in, it's starting to gain traction to use ECM motors. I work in the pump industry, so it's starting to become more and more common. So I just thought to ask for situations like that as it gains traction. So
Agreed.
All right, thanks, guys. Let me see. So the time is now after 12. I want to I want to let everybody who's still with us know that if you need to drop off, that's fine. You will get credit for the course, or a certificate rather. And we'll also send you a link to the recording tomorrow. So if you if you want to hear the questions, you can hear them tomorrow if you don't want to stick around today. On the topic of credit, we actually got a question about that, and I am trying to find an answer to that. I may need to take that offline with who was it? That was Isaac. So I'll try to find your answer, Isaac. In the meantime, Norm asks, can shaft grounding rings be used submerged in oil?
We have applications that are oil, environments, but mostly they are in an oil spray environment, not in an oil immersion environment. So that's kind of what I would say to you. I would say if you can keep them away from oil, that's your number one option. Grounding rings can be put into the isolators that some motor types use. They can be put internal to the isolators by FlowServe and Garlock and AES Seal and others. That keeps them out of the environment. Or they can be protected a little bit with a slinger or a seal, a seal or a slinger cover. I would try to keep them out of the oil, but if they are in a spray environment, we've had good success. I'm not going to sit here though and say I recommend them to be immersed. We are looking at that though. We've been asked that by other companies. So I don't have the exact, I don't think we're ready to say for sure, let's go. But I think we're down the path of developing that right now. And keep your eyes open for announcements from our company on that, is what I would say for immersion.
All right, thanks, Ken. The next question is from Lynn, but you already answered that. That was about EGIS rings on the drive end and opposite drive end. So that was a no because it doesn't help with circulating current. Clyde had one about conductor size to connect the grounding rings to ground, but you already answered that. They don't get bonded directly to ground. They get bonded to the motor frame and from there to ground. And then there is Isaac. All right, so Isaac asked about NCEES record keeping, and what I can tell you, Isaac, and Adam had a related question, is that we got added to their list of we got added to NCEES's list of approved courses, I think you say, at least 5 years ago. And since then, I've never had anyone ask for the provider number or course number. We've given out certificates and haven't gotten any complaints. But if both of you email me to remind me, then I will be sure to dig out and find whatever resources that I have. But like I say, in the past, just the certificate seems to have been enough for people. So I can't answer that one now, and Ken can't either. So we'll move on to Charles's question. Charles asks, or says, Baldor has a large difference in pricing adders for internal versus external EGIS rings, with internal being costing at least twice as much. For factory installed EGIS rings, what type of EGIS unit do they use? Do they have clipped or pressed in or screwed? And Charles, I'll unmute you from our end. Okay.
Well, let me go to that slide. That what you said is actually opposite of what I what I would say. The motor makers first started to put grounding rings on motors, in what they call a mod. A mod, of course, is where the motor is already built on the assembly line without the ring, and it's even probably crated up and things like that. So let's say the factory makes the motor without the ring. They put it in a crate or however they package it and send it over to their warehouse. Many of them, or another building of some type, even if it's on their campus. And the cost of the mod is usually higher because, first of all, they have to get at the motor. Maybe they're industrious and they can only reach in there and get at it without just taking it out of the crate. But oftentimes they have to take it out. And then they have to do what anybody else would have to do. They have to drill and tap or use a conductive epoxy, and that's fine. And they do that. And then they crate it back up, and then it's ready to go. That usually takes longer and costs more for all the reasons that I just said. When they factory install, they know that the ring is going on as the motor is being made. And so when it's going down the assembly line, I've literally seen this myself. They use rings in a high volume fashion, same size, pay less for the ring. Then they put them on with screws like you could see in this slide, and they run those screws in with a nut runner, like an air-powered nut runner or a screwdriver. And it's zip, and that ring is installed. So the labor time is low, and they don't have to like uncrate it or all that. So my experience tells me mods take longer and are more expensive. Factory installed goes faster and it's cheaper. However, it takes a while for the motor maker to decide to factory install, because when they get a request for 1 ring, 2 rings, 10 rings, they're doing that with a mod. They're not going to change their whole line. But now they get requests for many motors with rings. Then they decide, okay, the volume is high enough, we're going to factory install. That usually reduces your costs significantly. That's my experience anyway. I do have a lot of really good contacts with the motor makers. So if you want to email me specifics about what it is you'd like to have a ring on, please do so. And I'll help you with that, and we'll get you the best deal possible in the scenario.
And on that note, I invited everyone to put their questions in the questions section of the GoToWebinar app. There is also a chat section, which is not good for asking questions in, but if you go there, you will find Ken's email address as well as my own there. So so if you need to contact us, you can either reply to the automatic emails that you get from GoToWebinar, or you can use our direct email addresses that you can find in the chat window. Okay, so so that was Charles. The next question comes from Ian, who asks, is there any potential that shaft voltage discharge can create communication issues with plant systems like field bus?
Absolutely. Absolutely. As a matter of fact, that's a great question, because more and more, that's what I'm hearing. More and more, the grounding ring is put on not just to protect motor bearings, but to bleed off unwanted shaft voltage spikes, because it will affect related electronic equipment, sensitive equipment. Now, I admit mostly that's monitoring equipment, but it depends. We had a situation where an electric car maker was installing the ring just to mitigate unwanted shaft voltages, because it was screwing up some of their audibility, like their radio and things like that. And you might hear that and go, really? I didn't know that could happen. Well, it happened with them, and that's why they were installing the ring. So that tells me, yes, for sure, you can have issues with your sensitive electronics. Also, the ring is sometimes put on other rotating elements So I've had the ring go on in paper mills on the rollers. There's other static mitigation methods that they use on the rollers, like linear products, and we all know that. But sometimes they can't install it for one reason or the other, and they want to bleed off unwanted energy. So they add a grounding ring right on the roller of the, the rollers that support the web in a paper mill. So we've had that been done in the past. I'm not saying it's widespread, and I definitely am not saying that's our main application. It's not, but it is an application that does work. So thank you for the question.
All right, thank you, Ken. Our next question comes from David, who said, great presentation, guys. Very valid comments and observations of problems we are seeing in maritime large motor applications with VFDs and converters. David, if you or anyone else is interested, we will be having a webinar specifically on marine applications. I am opening the calendar now. I believe that's going to be in March. I'm just double checking that.
We've got a mining one in March, Sean.
Okay, then shoot. Yeah, you're right. Okay, all right. So yeah, I'm pretty sure we will be having a marine webinar in April. So so watch your email boxes for invitations from us if you're interested.
Sean, we also we've got a case study on that, published.
Yep. We also have a study on a generator gearbox on a commercial ship. You can find that on our website under applications.
Yeah, that's a very good market. I mentioned the Navy earlier in my webinar today. We have also, though, grounding rings are installed on some of the ore boats that are on the Great Lakes. We've got them also on some of the fishing fleet out of Seattle. So we have had, quite a number actually of applications for onboard ships, because a lot of them they'll burn a little diesel and they'll power up, traction motor, and they use inverter technology for obvious reasons, saving of energy and, control and all that. So they do see the voltage build up on the shaft. That's an application that does exist, and it's probably very big, even bigger actually in Europe, for more grounding rings put on there. We've got a person working for EGIS over in Europe who's very knowledgeable about this, could get you more information if you needed it. And then also this isn't drive motors for maritime, but it's loading and unloading ships. We have a lot of them on the cranes and hoists, loading and unloading ships. Now, why isn't that used on all cranes and all hoists? Mostly because the duty cycle is not as high. So a lot of cranes that are in factories, they don't get used that much. Some hoists get used a lot, but not that much. But when you have the unloading of the ships, like at the docks on the coastal cities, those have a duty cycle of almost 24/7 on, and we have grounding rings on those, and that's related to maritime.
All right, thank you, Ken. Frank has a question, and this is I'll just read this out and put in my answer that when you have a circulating current, isn't that similar to creating a transformer? And I've actually found exactly that language used to describe the effect. I can't remember exactly how it's explained, but This is discussed in the IEEE papers that that you can find on our website under technical papers. So it may be that the windings act as a primary and the stator and rotor together act as a secondary. I'm not sure. But that was a good insight there, Frank. All right. Another question from Charles here, who's still unmuted actually. Is the colloidal silver required when Baldor motors installed when installed when installed at the motor factory? The colloidal silver does add additional cost.
I'm going to go to a slide here in a second. I'm just trying to get there. Yeah, it does add cost. Yeah, there's some cost. So the history of that silver colloidal paint, it's on this slide here, right in the middle there. You see that under specifications that says ships with CS015 colloidal silver shaft coating. So what happened was many years ago, like at least 15 years ago, rust is non-conductive, okay? And we found that in some applications that are exposed to high humidity or moisture, like paper mills, or other applications where you have motors that run seasonally. There are some condenser or cooling tower applications or even heating applications where the motors run seasonally, so they sit for months at a time without running. Or motors that are in storage. We have had some air handlers that were delivered to a hospital and they were early by like, I don't know, 6 months or something, which I guess is rare, but okay. So they threw a tarp over them, you know, and that's great, except underneath that tarp is like a greenhouse. And they had rust form on the shaft OD. And that was at Northwest Hospital, actually, in Arlington Heights, Illinois. And that was an application very similar to what you're asking. Smaller motors, HVAC motors. And so anytime we saw that rust could form, we needed to work on that because it was breaking the conductivity between the steel and the tips of the fibers. So again, I'm going to go back to this slide right here. Remember, those tips of those fibers have to touch the steel, right? So if rust is there and the fibers are not making contact, or even the ones that are close, they can't transmit that energy through the rust. So we realized that's a problem. It's easy to find a coating that will stop rust. There's lots of them out there, but almost all of them are non-conductive. So we found one that is conductive because it has colloidal particles, colloidal meaning very small particles of silver in it. And those silver particles are brushing into the machine lines on the shaft OD instead of brushing off, so it lasts a long time. And we said, hey, you might want to use colloidal silver when you have a possible corrosion layer forming on the shaft OD, and that is used to this day. However, the motor makers typically do not install that. Many reasons. One is because 99.99% of our applications do not use the silver paint, and they work fine. We've got many test results from air handlers to pump makers to engineering firms validating the ring's function. And so it's just not needed. It's just, so we say, look, it's more of a recommended product, not a required product. We have no problem if anybody wants to put it on. It's relatively easy and it dries quickly. But when you're putting rings on in a high volume, fast speed environment, and also you don't see any problems with typical applications, then it has not been used in those applications. So sorry for the long answer there, but that question does come up quite often.
Okay. Can you hear me?
Yep.
We do a lot with Baldor motors, and when we do price, I'm mainly concerned with the pricing. The seminar is great that y'all are doing. It's very helpful. So we're pricing out of their mod book, but we tell them that they just buy it as a custom motor. So do you interact with Baldor quite a bit as far as them putting them on when they make the motor? Or do you have any feel for your relation there, interface with Baldor?
Oh yeah, a lot. Are you talking about the silver colloidal paint here now, or are you just talking about putting a ring on?
Well, putting the ring on. So most of our work it can be in a moist environment. We're in do water and wastewater. So sometimes the motors will sit for a while before they get installed. But we're in a wastewater environment, so there's a lot
Yeah.
of humidity there. I would like to have Baldor, install install internally, I guess. So I'm looking in your book. You've got internal and external on the mods. I don't know if Baldor at the factory installs them. Are they screwed in like you showed on your slide there, typically on the inside of the motor, or do they put them on the outside with clips?
Either. They do both. So the way this has gone is, and I know the motor makers pretty well. I have relationships with all of them. I have relationships with people that are working there that are very smart. They're experts regarding motors. Okay. But I'm also going to tell you the truth. They are not chomping at the bit to add grounding rings on motors. Okay. That's just the truth. And that occurred to me within a month of when I started working for this company in 2008. We went into a motor maker and they said, we love the ring. It's really good. We tested it and it works. We're like, great, that's great. Are you going to put any on? And they said, no, we're not. I said, why not? Well, they cost money and it costs us to put them on and nobody's going to want to pay for them. So the motor makers have taken an approach that we'll do whatever the customer wants, but we're not going to run around and do stuff just for the sake of doing it. We're not going to put a bunch of things on motors that we're not sure the customer wants. And that would increase cost, increase lead time. And it's going to hurt us if we do that. So we're not going to, put a bunch of stuff on there that they don't want. And so we needed to go out and create the market. So we do trainings like you just had here, the webinar. We do in-person trainings. We do field visits. We do a lot to educate the market. And we're not trying to ram any grounding rings down anybody's throat. We're just saying, look, if you've got motors on drives, you should be at least aware of this problem and you should be checking it out, because lots of times people are not aware of it. And then if you have a problem, the solution is to add shaft grounding. And how are you going to do that? Well, you can put them on yourself, but that's kind of hard because nobody knows really how to do it. And then you pay more for the rings when you only go out and buy one or whatever. So how do you get them done? You get them put on by the motor maker. That's the most cost efficient way to do it. So over the years, they've listened to their customers, which is you, and they've added them. They have added them like this slide shows right here. But honestly, it takes a little pushing to get that done. It takes a little influence. So you have to tell your supplier of motors, be it anybody, Balder likes on this slide here, or anybody else, we want this ring on there, and you can't back down. It's up to them to put it on in a mod or factory installed. That's up to them. Factory installed ends up best, but they're not going to do that until they need to, or they find that it's reasonable. Lots of times they put them on with a mod. A mod is almost like you're looking at here on the top. They do just like, one, or they do just some on the middle. So mods are slower and more expensive than factory installed usually. You got to make them do it. So like this company right here, they had a lot of problems with these hollow shaft motors on this slide. They had so many customers coming to them saying, we're tired of these bearing issues on your motors. They decided to add the grounding ring without anybody asking for them. So this right here, they put grounding rings on these motors without you even asking. It's not like yes or no. It's always yes. Here's another one. They put grounding rings on these Cymax without you even asking. So I don't know how long all of us are going to live or anything like that, but if we live long enough, we're going to get a lot more of this where they put the grounding ring on without asking. But it's a slow go. It's honestly a slow go. You need to tell them what you want and don't back off, because they would rather not. That's just the truth.
Yeah, they don't have a problem putting it on. I'm just trying to price them from my end of it. Every engineer that we do municipally, every job requires the Aegis shaft grounding ring or equal.
They do. We're in a lot of specs. Another way to do it is wherever you buy the motors from, if it's a repair shop, they can put them on, you know. So that's a possibility.
Yeah. Could you offline send me some information on the WEG with that marathon motor? Because that sounds very interesting. We may switch over to
and you
standard.
Yeah, you either, Sean, you need to capture this man's email, or else whoever I'm talking to, you need to email us so I have your email. I can reply.
Okay. Yes. What is yours? I have your name, but what's your email?
I put both of our emails in the chat section. You can get them there.
Chat section. Where's
It's near the bottom from my view. I think it will be for you too. On mine, it's underneath handouts.
oh. Okay, I see questions. I don't see the chat though.
Oh, very strange. All right. Okay. The easiest thing to do is just info at our website, info at EST-AEGIS.com.
Okay.
I will get that and I'll respond or forward to Ken.
Okay. All right. Thank you.
Hey, don't forget to do that, because I got a meeting with the marathon sales manager Tuesday, and I'll if I get your info, I'll have a nice example to show him, and that will help.
Okay. That'd be good. Thank you.
All right. Thank you, guys. Up next, a question from Scott. And I partly answered this, but it's of interest to other people, I'm sure. Are there any differences noticed on discharge characteristics for inverters with output filters?
Oh yeah, there are. And we always recommend you consider using those. And we're never going to say, don't do, this or don't do that. You should do anything you want to do and can do to eliminate these problems. So, here's our slide showing the scope reading. Output filters can be helpful because they're on the output side of the drive, and they will help, mitigate some of the voltage spikes going over to the motor. And that typically can help, not eliminate, but it helps the amplitude of some of the voltage spikes. So the beauty of it is use whatever you want. I mean, I would say sine wave filters, that's what I call them, but there's other names, are pretty useful on the output side of the drive. They're not cheap, but they're pretty useful. Other companies do stuff to the power input of the drive. I don't find those quite as useful. That's just my experience. But the output side, I find that to be useful. That Oceanarium example I gave in the webinar a half hour ago, that was a place where they added the sine wave filters on the output side of the drives. And then they added the grounding rings as well, and they solved their problem. So I saw that firsthand. That worked. It really worked. And those drives were hundreds of feet away from the motors. And that's just the way they put them in, and they had to deal with it. And that worked. The sine wave filter and the ring in combination. The sine wave filter helped, and the ring took the rest of it off. And I would encourage that all the time.
All right. Thank you, Ken. Got another question from Scott. And Scott, you are unmuted from our end, by the way, if you want to talk to Ken. Next question is, a newer version of adjustable speed drive manages motor torque control using a different method than variable frequency. Any experience with that style of drive?
Now, I don't have experience with all styles of drives. I'm not a drives expert, but I will say this. This right here is so important because every webinar we do, there's questions that people ask, and Sean and I don't have all the answers. We have a lot of answers. We don't have all the answers. So anytime you have a concern and you're not 100% sure of what's going on, you should measure some shaft voltages like Sean's doing in this photograph right here. It's pretty easy. It's not very expensive. It doesn't take long. And then you know your answer. It's better to know the answer because you measured than to surmise what the answer might be because Sean or Ken gave you some info. You know, there's upgrades going on all the time with motors, with drives, with everything. And maybe you get a nice combination of a motor and a drive, and the motor is close to the drive, and the cabling is right, and the grounding is right, everything's right. And maybe then you don't have much shaft voltage buildup, but you know, that's still the word maybe. I would verify with the scope to give you a better answer.
Thanks for that information. I appreciate it.
You're welcome.
All right, thank you guys. We have a comment from David who mentioned the marine applications earlier. He pointed out that, and this is about marine, but it applies to any industrial use or commercial for HVAC. VFDs are used for energy savings, but the fuel saved, or just electricity saved if you're running off the wall or off the line, the fuel save doesn't take account of the damage from high frequency induced voltages, and operating expenses then increase.
Yep, you are 100% correct. And that's why we're doing this this webinar. You can get energy savings. We all know that. Everybody likes it and it works and you get them. Well, we want to help you sustain that. If you get all kind of, you know, that oceanarium example I gave you, that oceanarium, that is in Chicago, okay? That was an aquarium. But about 30 years ago, they changed that over to saltwater, so it's an oceanarium now. Well, about 8 years ago, they called us in there and they said, hey, come on in, we have problems. And we're like, okay. So we showed up and we said, what's going on? They said, well, they told us to add drives to all of our pump motors, add drives, because they save energy. And we're like, oh, they do. That's right. Good idea. And they said, we added them. But now we got so many motor and pump bearing failures, we can't keep up. We cannot afford to have failures because then the ocean life, the aquatic life is belly up in the tanks and very expensive, very expensive. And we're like, we can't live with that. So what's the problem here? And we said, well, did they ever tell you about shaft voltage buildup? They said, no, they never told us. So we've experienced that hundreds and hundreds of times where drives are added without using best practices. Nobody told them about sine wave filters. Nobody told them about shaft grounding rings. Nobody told them about proper cabling, proper grounding of the frame, proper grounding of the system with high frequency braided strap. You know, nobody told them how to size the ring right, how to get it put on right. They just said, here's your drives, plug them in, you know. And that occurs in marine applications or anywhere else. We had Progress Rails, the old Electromotive. Electromotive was making heavy duty locomotives for years. And now they're owned by Progress Rail and they experienced the problems with their locomotives. Nobody told them about that. They had to find out for themselves. And they found out for themselves and now they mitigate the problem. And I think that happened 6 or 8 years ago. And they have no problem since then. They're using the grounding ring ever since then. And it works great. And they don't have a problem. Now, I know they don't make that many locomotives, so I'm not telling you it's thousands and thousands, but it's hundreds and hundreds every year, okay? And for 6 or 8 years, they've totally mitigated their problems. The Oceanarium, they reached out to me last year. They still have no problems. So when they use the sine wave filters and the grounding rings, it worked. And, you know, that's just the real world. Sometimes they just don't tell you, and you gotta do it yourself.
All right, thanks, Ken. It is almost 12:45, and we've still got questions coming in. Sterling asked, and I partly answered this, so I'll just repeat it for everyone. What about the drive motors in electric vehicles? I have not heard of bearing failure on those, but those are high power VFD applications. And Sterling is right in that. Electrical bearing damage and also EMC problems with interference are also an issue. And those are, we are involved with some electric vehicle makers, and the problems are only going to get worse because automakers are moving from silicon drives, which you know, they're usually like, I don't know, 400 maybe 600 volts, and they have high switching speed, but they're moving to so-called high band gap drives, which have higher voltage, 800 volts, and even faster switching speeds. And the faster switching speeds means that you can the voltage can build up faster than it can discharge, so you end up having more damage done that way. So I just wanted to put that one out there. Thank you, Sterling. And the next question is from Carlos, who asks, can you repeat why you only want one grounding, why only one grounding ring is enough? Does it apply even if both bearings are made of metal, no insulation or ceramic bearing?
Yeah, you want only one because you will have a circulating current problem. Look at this slide here. On the right-hand side of it, you get that red there. You get that, see those red arrows going around that motor? The ring will enhance or help circulating currents if it's on both ends. As Sean said, it will be enough so that it doesn't all go through the rings. It goes across the bearings as well as through the rings. And you don't want that scenario. So the insulated bearing, be it a ceramic ball or be it ceramic coating on the OD of the race, breaks that circulating current. And that's why you don't want a ring on each end. Now, I'll be honest with you, I've seen a ring put on both ends. I've got a couple of applications I know of, but that's just what they wanted to do. And they decided to do it regardless of our recommendation. And they didn't really have too bad of a circulating current issue. They did have an issue, but it wasn't catastrophic or anything like that. They decided that's what they're going to do. So I'm not going to say you can't do it. It's your decision. We're just saying it's really not best practice, and it's not. We don't have a long list of success stories in that area. I'd like to say we do, because then we could double our sales, but we don't. So the one company that wanted to do that, we cautioned them, and they did it anyway. And that was only about 6 months ago, though. So they haven't really seen too many problems, but they've only put it on a few motors, and they're kind of watching. So I would say normally it's not a best practice.
All right, Ken, Carlos says thank you. And let's see, we've got another question from Clyde. If you don't mind, Ken, I'll field this one. Clyde asks, has anyone in your company ever compared the EGIS scope with a Rogowski coil measurement? And for those of you who don't know, Rogowski coil, you know, our scope measures high frequency voltage. Rogowski coils are used to measure high frequency current. It's actually a kind of a transformer. It generates a voltage in response to the current, technically, but you use it to measure current. The problem is Rogowski coils with drives are usually used around the cabling, the power cables, and there is a whole bunch of noise current in there, there's much more noise in there than actually ends up on the shaft or moving through the bearings, at least as far as shaft voltage discharge goes. Circulating current is a different thing. But the point is, it's a comparatively small amount of charge that's stored in shaft voltage that moves through the bearings. The amount of noise current in the cables is huge next to that. I think, I'm pretty sure it's at least 20 times bigger. So measuring the common mode current with the Rogowski coil doesn't tell you anything about how much shaft voltage is building up or how much damage is being done when the shaft voltage discharges through the bearings. All right. And then Clyde had another question. Just another observation that cabling with 3 conductors and 3 conductor ground and twisted shielded conductors are extremely important, and that's absolutely right. Having good VFD cable can avoid all kinds of problems. It contains the noise and prevents it prevents interference with other systems from the drive. It doesn't typically help with shaft voltage discharge, but nevertheless, whether shaft voltage discharges through the bearing or whether it goes through an EGIS ring into the motor frame, it then needs to get back to the drive somehow, and a good VFD cable will give you a good low impedance path back to the drive. And that looks like the end of our questions at just before 10 to 1. So, all right, for those 50 of you who stuck it out through to the end, I salute you and thank you for your questions and your attention. And if you have any questions, you can always you can reply to the automatic emails you get from GoToWebinar. Those come from info@est-aegis.com, and I monitor that box. So if you say anything, I'll get it there and we'll forward it to the appropriate people. And thank you all again, and have a good day.
Thanks, everybody. Have a good day.